All right, so let's get started. Can you guys hear me okay and see the full board okay? My hand visible in all the corners of the board? Okay. All right. So while we are waiting for a few more kids to join, let's get the ball rolling. So today we are going to talk about some inverse trig functions. Hi Samriddhi, you're just on time. I unmuted myself to say what we're going to cover today. So we're going to talk about inverse trig functions. So before I start talking about it, I want to understand from you guys what is that you are aware of with respect to inverse trig functions. What does it do? What exactly it is? We all know trig functions, right? We know sine, cos, tan. Hi Kushi.
Hi.
Okay, so we are just starting the class. So what I was saying was we are going to talk about inverse trig functions in the class today. So far we have talked about trig functions. What is sine, cos, tan? How do we deal with different concepts of periodicity or symmetry, and then we looked at different problems and all. Today we are going to talk about inverse trig functions. Hi Vishal. So my question to you guys is, what exactly is your understanding of what is a inverse trig function? Any thought? Right or wrong doesn't matter. Yes, Vishal.
I know that the inverse is they're like the opposites of sine, cos, and tan.
Okay.
I think they're like the opposite value type.
So
I know that they're like 1 divided by theta or something.
1 divided by theta. So you're saying that if I say sine theta is a trig function, sine 1 divided by theta would be the representation for inverse trig function?
Yeah.
Okay. Hi Tony. So we are starting with inverse trig functions, and I will give you guys those 10 seconds to think about it and try recalling what is that you know and how is your understanding different from Vishal. Okay, while I'm closing the garage door because everybody is online today. Okay, give it a try. Right or wrong doesn't matter. I'll make sure that I'm holding the sky that it doesn't fall if you give a wrong definition. Yeah, Praneeth.
Like sine to the power -1.
Sine to the power -1. Okay. So you're saying that if sine of theta is a trig function, it means something. Depending on the value of theta, sine of negative theta. Is that what you're meaning by that? Okay. Yeah, Vishal. You are getting tempted to say something more.
I agree with him.
You agree with Praneeth? Okay.
Yeah.
Let's see what Saket, Sahit, Khushi. Guys, don't be shy, okay? This class, I want you guys to be as brave as you can think of. Be it wrong. Yes, David, give it a try. I know you're juggling between classes, but still, give it a try.
Yeah, hold on. I'm about to rejoin, so.
Okay.
I just joined on my phone to listen. I'm about to rejoin on my computer.
Okay. But you're being online, right, David?
Yeah.
Okay, because I've closed the garage door. If you're coming to the classroom, knock the door. Alright, I will let David join. And then, so Praneeth and Vishal, since you guys are saying that if sine of theta is a trig function, inverse trig function will be something like this. Now, help me understand this. If I say x to the power 1 is x, if I say x to the power -1, it becomes 1 over x, correct? So how is this thing different from this interpretation? Give it a try. I'm just making you guys think. Saket, any idea, beta? Thinking? Kushi? Yeah, Praneeth, go ahead.
Well, in this x way of representing this, so this x to the power 1 will give you a linear equation, while x to the power -1 would not. It's like a little different.
Okay. Vishal, are you trying to say something? Alright. Let me. I don't think telling you guys are.
What is there?
No, you had raised your hand, so I was just checking if you are wanting to add something more to what you said. Kushi, anything that you want to share with us?
No.
No? You guys are afraid of talking to your teacher? Okay. Don't be afraid. I try my best always to make sure that I don't look scary to you guys. Okay, now let's look at a simple triangle, a right angle triangle. Okay, let's say this angle is 45 degree. This angle will also be 45 degree. Yeah. Or let me do one thing. Let me go back to the unit circle, because you guys are more comfortable seeing unit circle than seeing a regular right angle triangle. So let's look at this is a unit circle. Tony, are you with me, brother? Yeah? Okay. Just make sure that you guys, whenever I'm getting you guys confused, raise your hand without any fear, okay? So this is my unit circle. When I say unit circle, I'm saying my radius is 1. Now, what I'm trying to do is, let me try, this is my x-axis, this is my y-axis. Let me try drawing a line, this line, such that this angle is 45 degree. Okay? I picked up a point on the perimeter such that when I join this center with that point on the perimeter, this angle is 45 degree. So far, okay? Now, I'm dropping a perpendicular from here to here. Let's say this was O, this point was A, and this point is B. So far, my drawing is not bothering you, Saket, everybody okay?
Yes.
So this is my unit circle, meaning my radius is 1 unit, regardless whether it's 1 millimeter, 1 centimeter, 1 mile, 1 kilometer. Yes, Davik, you're saying something.
I can't really see the top half. There's like a lot of glare.
A lot of glare. Is it slightly better?
Yeah, it's a little.
What I will do is, I will make it darker. Does it make it better?
Yeah.
Yeah? Or make it even darker. Okay? At least you guys can see it, right? So this is my unit circle. I picked up a point A on the perimeter such that when I join the center of the unit circle with that point, this line makes 45 degree with the x-axis. Okay? Now, if this is 45, and from this point I have dropped a perpendicular on the x-axis, so this angle is 90 degree. This angle is how much? 45. So far it's okay. I'm doing easy stuff. Now, if I look at this right angle triangle OAB, this length is 1. Now, what I'm seeing is this side and this side will be the same. Eventually, this OAB, triangle OAB, is an isosceles right angle triangle, meaning two sides are same, because these two angles are same, these two sides will be same. Yeah? Kushi, Tony, do you guys agree? So here's the deal, okay? If you're talking about an isosceles triangle, you're talking about the two sides of the triangle being same. When the two sides are same, the angles opposite to the sides will also be the same. So in the case here, what did we do? We have drawn this right angle triangle in such a way that this angle is 45. Obviously this angle will be 45 because when I draw the perpendicular, so all the three angles is 180 degree. Okay, so these two angles are same, 45 degree. So this side OB, meaning this side, and this side AB will be the same. Yeah? Kushi, do you agree with her? Yeah, okay. So now in this triangle OAB, what I'm saying is this angle is 45, this angle is 45, this side and this side will be the same. Now I don't know what is the length of this side. Let's say this is x. So if this is x, this will also be x. Let's find out the value of x. So this, what the Pythagorean theorem says, a square plus b square will be equal to hypotenuse square. So x square, this side and this side both are making 90 degree. The square of x plus square of this x will be equal to hypotenuse square, which is 1. So 1 square. So it became 2x square equals 1. That means x square equal to 1 by 2 or x equals 1 by root 2. Up to this much, okay? Okay, so that I'm replacing this x with 1 by root 2 and replacing this x with 1 by root 2. And you guys must be thinking that why is the teacher trying to do something that we have done 100 times? There is a reason for it. Now this is a right angle triangle OAB. We know all the three sides. Now let's look at, if I am taking this angle theta as a theta. So sine of 45 degree, sine of theta is side opposite to the angle divided by hypotenuse. So it equals 1 by root 2 divided by hypotenuse, which is 1. So this becomes 1 by root 2. Sine of 45 is 1 by root 2. Same way, if you try finding out cos of 45, this is my angle 45, I am picking this angle. So cos of the angle is what? Adjacent side by hypotenuse. So adjacent side is also 1 by root 2 divided by hypotenuse, which is 1. The radius of the unit circle. So cos 45 also gave me 1 by root 2. So basically, in the previous classes when I was saying that sine 45 is 1 by root 2, cos 45 1 by root 2, when I was drawing the table, when I was showing you the value of all the sine angles, we have just proved that one more time. But the agenda is not that. I'm not trying to prove the value of these angles or value of these trig functions for the angle 45. Tan of 45 will be sine 45 by cos 45. So 1 by root 2 divided by 1 by root 2. Divided by 1 by root 2. That becomes 1 by root 2 times root 2 over 1. Again, it became 1. So what we got from all that easy stuff that I was doing was, from this triangle was, these three values. Sine 45 equals 1 by root 2. Cos 45 or cosine 45 is 1 by root 2, and tangent 45 is equal to 1 by root 2. 1. Okay? Up to this much, okay, right? Nothing bothering. Kushi, Samriddhi, Davik, everybody okay? Tony okay? Yeah. Alright. Now, the inverse function says, okay, now what we have here is trig function sine 45 equal to 1 by root 2. Trig function cos 45 equal to 1 by root 2. Trig function tan 45 equals 1. The when you read this thing in a different way, now we know that sine of 45 is 1 by root 2. If I want to figure out what is the angle for which value of the trig function sine is 1 by root 2. This is called inverse function, inverse trig function, meaning here you know that value of the trig function equal to this value. If you want to figure out for what value of the angle sine inverse of 1 by 2, for what value of the angle the sine of the value will be 1 by root 2. For what value of the angle cos value of the cos trig function will be equal to 1 by root 2. For what value of the angle tan of the theta will be equal to 1. Let me try writing it down so that you know. So here we know the angle for which we are finding the value of sine, cos and tan. So these are the trig functions. Now we are saying what is the value of theta for which sine value is 1 by root 2. So you don't say sine, you say sine inverse, or you say arc sine. What is the angle for which the sine value is 1 by root 2? And here it will tell you, okay, it is 45 for which value of sine theta is 1 by root 2. So basically inverse trigonometric function is inverse of the trig function. In the case of trig function, you say, okay, if I know the angle, the sine of that angle is this much. Inverse function or inverse trig function looks at it differently. Say, okay, fine. For what value of the angle, my sine value will be this. For what value of the angle, my cos value will be this. For what value of the angle, my tan value will be this. And I cannot say sine, cos and tan. So this is represented as sine inverse. So now if you relate it back, like sine of 45 is equal to 1 by root 2. So the way you will write this inverse trig function would be sine inverse of 1 by root 2 is equal to 45 degree or pi by 4. Or you can also say arc sine of 1 by root 2 is equal to 45 degree. So inverse trig function tells, in the trig function you get the angle, you get the value. Inverse trig function says that you have the value of the sine, cos and tan and you are trying to find out the angle. So if you relate it back to the function concept, right? We are saying these are trig functions. What is a function? Function is like this. You have a set of inputs which you call as domain. You get a set of outputs that you call as range. This is your domain and this is your range. Every input gets you an output. Every input gets you an output. Here you are talking about trig function. Okay? So here you are giving the angle, let's say pi by 4 or 45 degree. In the sine, cos or tan, you get 1 by root 2 or 1 or whichever trig function you are using. Now the inverse trig function says, you know which trig function you are talking about and you know the value of it. From that, can you find out the theta for which your trig function is this much? So let me pause there for a second. Am I making sense to you guys? Let me repeat one more time. Yeah, okay. Let me repeat one more time. You have the value of the angle, you put that in the trig function, you get a value. So you have a domain of the as your angle and you get the value of the trig function as a range. Now arc sine, arc cos or arc tan or inverse trig function basically says, okay, you know which trig function you are talking about and you have the range value. From that, can you derive your domain? So you are looking at it in a different way. In this case, you know the angle, you get the value. Here in this case, you know the value and the trig function, you have to find out the angle. That's the only difference that inverse trig function brings in our life. Did I make sense? Little bit. Tony, Davik, Samriddhi is quiet. Now try to figure out to say yes or no. Okay, how about Sahid? Sahid is saying no comments. Sahid, is it okay to digest?
Yes, sir. Yeah.
Okay. How about Saket? Fine so far? So basically, a summary of what we have seen so far, and I will try not to stress this too much, because if I stress this too much, it'll break. It doesn't have enough content to be stretched. As long as we know the trig functions, as long as we are comfortable with the unit circle, as long as we know what is symmetry, what is periodicity of, with respect to a trig function in unit circle, and we are clear about the concepts, trig function is, inverse trig function or arc sine, arc cos or arc tan is just the reverse of it. You have a domain, you find the range. You have the range, find the domain. That's how you look at it. When you're traveling from domain to range, you're talking about trig function. When you're going from range to domain, you're talking about inverse trig function. And that's fair also, right? I mean, you're inverting the whole flow. Yeah? Is that digestible so far? Everybody? Now there is one more thing. I will delete one circle and we'll play with the ellipse for 2 minutes. And there is a very strong reason for doing that. So, and David and everybody just confirm me if the board is rightly visible to you guys. Yeah? Okay? If I need to make it thicker, I will do that. Okay? So this is, I'm calling this egg as my domain and this egg as my range. Okay? So you are giving an input. Here my inputs are angles. Okay? And here in the range my output are values. Absolute values. So here angles go as an input. Let's say let's talk about trig function sine. Okay? So sine 30 degree or pi by 6 radian. I'm just putting them side by side. 45 degree or pi by 4 radian. 60 degree or pi by 3 radian. 90 degree or pi by 2 radian. Okay, these are my inputs. Okay, same thing, two different units of measurement used. Okay, and I'm applying sine here. Okay, so sine of, so here will be 1 by 2, 1 by root 2, root 3 by 2, and then 1. Sine of 30 degree or pi by 6 is 1 by 2. So when I am applying the function sine, okay, I'm just representing that in some layman's way. Okay, so trig function of sine, I am getting 1 by 2 for 30 degree or pi by 6, and these are the values that you would have seen before. I'm not stressing on that, but if you don't remember, assume that this is the value. I'm not bluffing. Okay. Sine of 45 degrees 1 by root 2. Sine of 60 degrees root 3 by 2. Sine of 90 degree is 1. Okay? Now, inverse f, I'll say sine inverse, or let me say arc sine. Arc sine 1. Arc sine of 1 will give me angle pi by 2 or 90 degree. Arc sine of this will give me root 3 by 2, and so on and so forth. I'm not wasting time for everybody. Okay? Now let me just draw a tiny circle here and look at this. Is every value of 1 and arc sine of that is only pi by 2, or there could be multiple angles based on your understanding of unit circle? What do you guys think? I'm saying, is every arc sine or inverse trig function of 1 will give me pi by 2? Yes or no? Davik, Tony, Samriddhi, Praneeth, you guys are saying yes, and I'm saying no. Yeah, I got one vote. Praneeth is saying no, and I'm agreeing to that. We'll come back to this, okay? And we'll come back to that, and that's a very important concept. So here, sine of 90 degree or pi by 2 is 1. But is every arc sine of 1 only pi by 2? Answer is no. Because if you go back to unit circle concept, you will see that sine 90 is sine 90 is 1. Sine, again add 2 pi to it. So 90 plus 2 pi, 90 plus 364 for 12, that is also 1. Again add 2 more pi, that is also 1. So this 1 doesn't hold true. So when you are going from here to here, you are putting that input, you will get only one value. But if this is a value, if you are trying to find out the arc sine of 1, you will get sine pi by 2 equal to 1, sine 2 pi plus pi by 2 equal to 1, and keep adding 2 pi to it, and you will get all ones. Meaning, every value of this is not referring to only one in the domain. There could be multiple. And that is when you will say, there's another concept called invertible function. If for every input you have one output, and every output gives you only one input, this is called invertible. The function is invertible. You can invert, you can flip between domain and range. But if any output refers to multiple inputs, then that is not invertible. This function is not called invertible. So in case of all these trig functions, they are not invertible. And you can make them invertible only by restricting the domain. You will say, okay, fine. This value holds true. Now let's look at it. Let's say arc sine 1 equals pi by 2 if theta is less than equal to pi, or let's say 180 degree, and greater than equal to 0. You are restricting the range in which you are contemplating the value of theta or the angle to make it invertible. So I know it's a loaded thing. First thing first, we learned about what is an inverse function. Inverse function is nothing but you have an angle, you find the sine, cosine, tangent value of that by using the trig function. Inverse function says that for the output, what is the angle that gives you this output? That is one thing we looked at. There's no new concept, we just related with what we knew. But based on our understanding of the unit circle, we know that on the unit circle, when I keep making rotations, my angle keeps changing, but my sine value, I might have the same value after making every rotation. So that means for this one output, there could be multiple inputs, multiple angles that will result to this output. So when you see a one-to-one relationship between domain and range, that is called an invertible function. When that is not the case, you will say this function is not invertible. So all the trig functions that we know of, they are not invertible because there could be multiple values which will result or map to different inputs. So these are called non-invertible functions. And you can make them invertible by restricting your domain. You will say, okay, fine. This value holds true only for this range of angle. I am not going to go beyond this angle. And you guys must be thinking that it's getting little too complicated. And I agree. And now what we will do is we'll try making it simpler. But so far, whatever we have discussed, tell me what is the level of confusion we have on a scale of 1 to 10. And be honest, it's okay. I'm going to make sure that the scale comes down. Tony, Davik, Khushi, what would be your rating of the scale of complexity based on whatever we have discussed so far?
Out of like what number? Or like,
Give me a range.
from 1 to 10, I'd say it's like a 3.
3, that's the level of complexity. How about Tony? And be honest with her, it's okay. It's my job to make it easier.
I say like a 6.
You say 6? Okay. Pradeep? I'm sorry?
Can you repeat the question?
No, I was asking, whatever we have understood or tried learning so far, it's not one of those easy concepts. So it is a little complex. So based on the way I have explained it, if you have to rate the complexity of the things that we are trying to understand, how complex you would find on a scale of 1 to 10.
I'd give this like a 4.
Okay. How about Kushi? Kushi is trying to avoid controversy. Okay. So anyways, I was asking this question for a reason, okay? Because whatever I am talking about in inverse function, that was easy probably. We are just looking at it differently. Invertible function, that is where things got a little messy and complicated. Now, let's go back to unit circle. And then it will start making a little more sense. This is my unit circle. So far, no problem. I come to a point, let's say P. This is, and this angle, let's say, is 60 degree. Okay? This angle I am saying 60 degree. So the coordinates of this point will be cos 60 degree, comma sin 60 degree. Yeah? That's what unit circle says. Any point you pick up, whatever angle that makes with the x-axis, cos of that angle and sin of that angle will be the coordinates of that point. Is that okay? Vishal, Khushi, everybody? Right? Saket? Yeah. So, now cos of 60 degree is 1 by 2. Sin of 60 degree is root 3 by 2. Okay? So that means cos of 60 degree from here to here is 1 by 2. And sine of 60 degree, meaning the y coordinate, is root 3 by 2. That is what unit circle says. Now, instead of cos theta and sin theta, you have absolute value also by knowing the value of those angles or those trig functions. Now, look at this. I am picking up another point here such that this height is same as this height, meaning root 3 by 2 here. So if I look at this point, I have just dropped a perpendicular, I have drawn a line parallel to the x-axis, and wherever it meets, let's say this is point Q, and this makes what angle? This angle is theta. Okay, I'm not confirming that right now. Let's say this angle is theta. Okay. What I've done is from here I've drawn a perpendicular so that this height and this height is same. I have drawn this line parallel to the x-axis, so this height and this height is same. Okay. Now this height, and from here I am dropping a perpendicular here. So if you look at this triangle and this triangle, both are congruent because this side is radius, this height will match, and this angle is 90 degree anyways. So these two are congruent. So this length and this length are same. But if you look at just this part, both are root 3 by 2 because they are congruent. So here this was making this angle, this total angle is what? Here to here is, total is pi and this is theta. And eventually what we found was this angle, these two triangles are congruent, so this angle will also be 60 degree. So this angle from here to here will be 120. Let me repeat what I am doing. This is my unit circle. I picked a point where this line is making 60 degree. Okay. And from unit circle it says any point that you pick on the perimeter, the coordinates of that will be cos of theta, comma sine of theta. X coordinate will be cos of theta, y coordinate will be sine of theta. Since we made 60 degree angle, it will be cos 60 degree, comma sine 60 degree. So far this is okay. Now, from this point, we are trying to draw a line parallel to this line and it eventually meets at point Q. Why we are drawing parallel? Because so that the distance between this point to this point and this point to this point is the same. Okay? When you draw a parallel line, right? And distance between the two, any 2 points, perpendicular distance between the two lines will always remain the same. So that's why we have drawn this line parallel to this line. So this distance and this distance are same. If this distance same, this is the radius, and from here we have drawn a perpendicular again. So this is right angle triangle, this is right angle triangle, and they are congruent because your angle is matching by theorem RHS. For two right angle triangles, if hypotenuse and one of the side match, they are congruent. So this angle is 60, this is also 60. So now you are saying that okay, this length and this length are same, this length and this length are same. So here, and this angle will be equal to this one. So here to here this angle will be 120 degree. So here the coordinates will be cos of 120 degree, comma sine of 120 degree. And what you know is your x coordinate here is positive, this is negative, but your y coordinate here both are positive. So cos of 120 degree and cos of 60 degree are both the same. Cos of 60 degree is equal to cos of 120 degree. That's what we are seeing just now. Is this okay so far to digest or to follow? Saket, Kushi, stop a bit, okay? Because I would explain things the way I understand, but it is very important for me to make sure that everybody in the class is able to follow me. Samriddhi, are you with me so far, beta? Okay, Davik. So from this one, what we found is this. Cos of 60 is equal to cos 120 with all that circles that I was doing. Now, let's go back to this concept of inversible function. If I have one angle sine, let's say talk about cos trig function cos of theta. When cos 60 degree, I got 1 by 2. Cos 60 is 1 by 2. Okay, not cos, let's say tan, sine, because that is what is matching. Sine 60 degree, I'll get root 3 by 2. When I'm looking at sine 120 degree, sine 120 degree, this one, that is also having same y coordinate. So 120 is also going to this. So look at this. This is a domain, this is a range. This one giving one output. This one is also giving you same output. So here, if your sine of 60 is root 3 by 2, inverse of sine root 3 by 2 will not give you only 60. It can give you 60 or it can give you 120, and then keep adding 2 pi to it. You will see more things adding to the confusion. This is not inversible function. If you have a domain and a range, every domain value should map to one and only one range value. And when you talk about the inverse function, it should map back to the same point. If it is not mapping back to the same point always as the only option, this is not inversible. Yeah? So you go from here to here using a function. When you do an inverse of that, you go back to this value. That is why it is called inversible. But in this case, what's happening? You give this value, find something, but this value is it is also obtained through multiple other inputs also. So when you are here and you are using the inverse function to go back to the input, you are landing in multiple places. So you are confused. That is where this function is not inversible. Trig functions are not inversible. Yes, Pradeep.
So any supplementary angle pairs would be non-inversible.
Not supplementary angle.
Anything that adds up to 180.
No, not supplementary angles only, because you don't have the problem only with the supplementary angle. You have problem with addition of 2 pi also. When you add 2 more pi to this angle, 60 degree plus 2 pi, you are landing in the same place and your y coordinate matches for the sine theta. So is the case with sine theta also. So supplementary angle plus this 2 pi value. So when you have more than one option while you are reversing back or inversing the function, you are not confirmed. You are not sure that whether you are landing here, here or here. And there are many more. A big 2 pi that you add to the angle, that lands in the same place. Your sine and cos value will be the same. Yeah? So, if we want to make our trig functions inversible or invertible, we have to say that this function is invertible only in this range. Let's say, now let's look at, if I am saying, okay, sine of theta equal to 1 by 2, where theta is less than equal to pi by 2 and greater than equal to 0. Now I am not leaving any opportunity for getting confused. Sine of theta will be 1 by 2 for only one scenario, that is 30 degree. Because I am not going beyond 90 any which way. As long as I am restricting my input, my domain, okay, this will be inversible. That within this range it is inversible. That is what is called constraining your trig function to make them invertible. Okay? Otherwise, it's like a free bird, it can go anywhere. Because you know that every time you make one iteration, you are landing in the same place and your x and y value will be the same. Only your angle keeps on changing. So you say, okay, sine 30 degrees is 1 by 2, and also sine 30 plus 360 is 1 by 2. And also sine 120 is also 1 by 2. And sine 360 plus 360, 720 plus 30 is also 1 by 2. So your domain and range is not consistent. Here you have only one path to go, but while you are coming back, you can land in multiple places because of this iteration across this unit circle. So if you want to kill that iteration thing, you will say this sine trig function is inversible if theta is, let's say, less than pi by 2 or less than pi, whatever way you want to restrict it, okay? To make sure that you don't come across the same value for the trig function within that domain. Let's take a deep breath and see who all are having any doubt, any question, any query. Feel free with it, it's okay. Saket, are you clear? Sahit, Praneet, Samriddhi, Khushi, Tony, Davik, Vishal. Okay. So here's the thing, okay? Now, don't think that I'm getting greedy, okay? I'm not greedy by any standard. But then, what I've started emphasizing is that I want you guys to start watching the video. Because whatever I'm doing, right, it's a quite loaded concept. I would want you guys to spend 15-20 minutes. Don't watch the entire 1 hour lengthy video, okay? Whatever preaching I'm doing, just skip that part. That's of no use, okay? But when I'm doing certain things, right, you will hear it like a speech from me and you'll probably end up forgetting it also. Very, very likely, very normal, okay? So after every class, spend those 10 minutes, okay? Skip the things where I'm unnecessarily blabbering, okay? I mean, I can't stop that, okay? I can't behave like a robot. Well, so today we'll learn this, class is over, right? So that emotional aspect of me that comes out, you would want to skip that part and then watch the video and then do the scratch work by yourself, okay? I want you guys to get to the practice. When I said I'm getting greedy, meaning obviously when you guys watch it, I'll get some watch hours from you guys. I'll get some extra views also, right? And YouTube might start paying me a few dollars for the extra views that you guys give me, right? But that is not important. What is important is to make use of the video for which we are making it, okay? Because nobody cares about me. There are teachers 100 times better than me who are teaching math, right? So they have more views, more subscribers. I don't care about it. What I care about is for you guys. That whatever we are doing here, try to watch it again and see, are you able to relate? And you doing, you observing me doing this whole thing would make you understand it. But if you want to keep it with you, obviously you would want to do the repeat of that by yourself. And that is where watching the video would probably help. So try doing that so that it fulfills both the purpose, okay? It fulfills your purpose of revising things and retaining it with you for longer time. And obviously it fulfills my desire of getting few extra views. So when you want to talk about the view story, right? Views, people get money for views. If I get 1,000 views, I'll get $5. So that is not significant. But if 10 of my students watch it and 5 of them get benefited, that is my takeaway. Okay, I'm not caring about those $5. That is not significant enough. Okay. So let's move on. Now what we'll do is, we talked about inverse functions. What is meant by invertible function? What do we mean by restricting the domain to make the trig functions invertible? Now let's look at some related problems that we want to take a look at to see whatever concepts we have tried to go through, how do we relate it and how is that helpful for us to solve few related problems. The kind of things that you guys will come across. So let's take one problem, okay? I know we don't have much time. We'll try solving one problem today. And then you guys can also give it a shot by attempting some unit test on Khan Academy. And then we'll try doing a few more problems in the next class before we jump on to the next topic. Okay? So I'm reading the first question. It says, the following are all angle measures in degrees rounded to the nearest 10th value, whose tangent is 2.6. Okay? I'm reading it one more time. The following are all the angle measurements. Let me write the options, okay? Then you'll be able to relate. 111.0 degree. Second one is 69.0 degree. Third one is 249.0 degree. Fourth one is 429.0 degree. Okay. Now reading the question. It says the following are all the angle measures in degrees to the nearest tenth. As you can see, that it's all to the 10th value. Whose tangent is 2.6. To tangent of the angle, whatever it is, theta is 2.6. Okay. It says which is the principal value of arc 10. Arc 10, 2.6. So it's like this. 10 of theta will be 2.6. We have been asked to find out the angle. So that's why it says arc 10 of 2.6 is equal to what value of theta. And you must be thinking that, okay, we have all four options. 10, 2.6, how do we relate to it? And how do we find it out? Okay? Yes, Pradeep.
I got B.
You got B? Okay. I'll come to you. I'm just curious to understand how did you approach it. Let's see what are the other options I'm hearing from all other kids. Samriddhi, Saket, Sahib, give it a try. Right or wrong doesn't matter. At least think of some approach in your mind and tell me why you are leaning towards an option. Vishal, Davik, Tony, Kushi, I want to hear everybody, okay? I'm not asking you guys to sing a song, just tell me the answer. And it might look little difficult to begin with, okay? But it might be sounding difficult to you guys because you are thinking so. Give it a shot. Okay, just because we are constrained for time, let's hear Praneeth. Okay, I'm not stopping you guys from trying, but let's hear what Praneeth did, and we'll see what was his approach. Yes, Praneeth.
So since we're trying to find the angle, we're given the value of a tan thing. We're trying to do an inverse, right? And because we want to do an inverse, it can be greater. The angle can be greater than 90. So A, C, and D are all knocked off because they're either greater than 90 or less than 0.
But how are you concluding that the angle cannot be more than 90?
Because we're trying to do an inverse of tan.
But tan of inverse you can always do for any angle actually. If let's say you say sine 40 is some value, sine 240 also we can do. Sine 240 is some value. So inverse of sine 240 will be that value of that will be the inverse function. So we are not restricted by. Okay, now let's break it down in a simpler way. Okay, ultimately what it's saying is find out the angle for which tan theta will be equal to 2.6. It's a positive value, correct? Now let's look at all these angles. How will you approach this? See, this is an elimination technique that we'll use. Okay? So now start with the most lame approach. See, we are not trying to talk about inversible function or not, okay? We are just saying find out the arc sine. If sine of theta equal to something, we have been asked to find out, okay, what is the sine if you know this something, okay? That is arc sine. We are not trying to prove inversible or not, okay? So it just saves. Now look at it. Tan of the theta is 2.6, meaning tan is positive. Now look at this one. In this quadrant, your sine is positive, cos is positive, sine is also positive. So if you are picking any angle between 0 and 90, that will be positive value. Yeah, tan theta will be positive because your sine and cos both are positive. This is positive, this is positive. So your tan theta will be positive. Yeah. Now if you go to this quadrant, here your cos is positive but sine is negative. Yeah. If you are picking any angle in this quadrant, your sine is your cos theta is positive but your sine theta is negative. Correct? So I can, if I am looking at 2.6, a positive number, I can look at this quadrant, but I will rule out this quadrant. Okay? Now look at this quadrant. If you are picking up any angle, your sine theta will be positive, but your cos theta will be negative. So you will rule out this quadrant also. Correct? Am I making sense to you guys or not? Tan theta is sine theta by cos theta. And your cos theta is the x coordinate value, sine theta is the y coordinate value. So any point, if you are coming here, your cos theta is this length, which is negative. Sine theta is this length, which is positive. So if you have to get 2.6, a positive value, you cannot talk about an angle in this quadrant. Okay? Now you look at this quadrant. Here your cos theta is negative, your sine theta is also negative. So this quadrant is also acceptable. So you are talking about only these two quadrants where your tan theta could be a positive value. Be it 2.6, 1.9, I don't care. Yeah. Now let's look at all options. Praneeth, am I making sense so far to you? Khushi, Saket, Samriddhi, am I resonating so far? Okay. So now let's look at the angles. Minus 111 degree, meaning I am talking about 90 degree. So I am talking about clockwise movement by 111 degrees. So 90 and 21. I am landing somewhere here. Okay, this quadrant, this is acceptable. Okay. Now 69 degree. This is in the first quadrant. This is also acceptable. So first two options are acceptable. How about this guy? 249 degree. So 180. 270. So this is also acceptable. We are coming here. This is the third quadrant. 429 degree is 360 plus 69. 360 plus 89, somewhere here. Okay? 360 plus 40 plus 29. Yeah, 69, somewhere here. So 69 degree here. This is 69 degree. This is 69 degree. And 249 is how much? 180 plus 69 here. This 60. So what we are seeing is these three are giving the same value, 69. Okay, this is 69. But okay, yeah, this is both are negative. So this one, and this one, both are equivalent to 69 degree. Let me read the question one last time. What does it ask actually? Whose tangent is 2.6? So 249, 180 plus 69. This is 69. So these two are same. And then 429 is 360 plus 69. So same place. Okay. So all right. So we are seeing three of them resulting into the same value. Okay. What we'll do is, let me not get you guys stressed out, but first thing first, what we were trying to do was we were given a tangent value and we have been asked to find out which of this angle is giving me the inverse of trig function. And now here you are saying that okay, whether this or this or this is where we will combine the inverse function or invertible function combination, and then we'll come to that one. So Praneeth, what you are saying, that might be the solution for this one, but we will add one more caveat to this, because right now it is not applying that constant thought. Okay, all the three options are matching the same angle. We will look at some more problems. This one is not solved yet. We will look at this one in the next class and we'll solve it together. Okay, yeah, but from approach point of view it will remain the same. You know the angle. Now 2.6, I'm just thinking about how do we break it down and rule out the unwanted options. Okay, so we will try solving this in the next class and try make it even simpler for you guys. Yeah, all right. So yes, Pradeep.
A also have a 69 value too.
A also will have a 69 value. Oh yeah.
Third quadrant.
Yeah, 90 plus 29. Yeah, 69, same value. So that is where we will see now this is a classic example where two concepts are coming together, right? All of this is resulting in the same absolute value. Now we have to limit it using the concept of invertible function, and we will solve it applying both the concepts together. Okay, so Praneeth, your answer would probably be the right answer, but let me explain that in a simpler, easier way in the next class, and we'll take it from there. Yeah, all right. So hope whatever we learned with respect to what is inverse function, inverse trig functions, and what do we mean by functions being invertible, at least concept wise we are okay. We have not practiced today. We'll practice few problems in the next class. All right. Okay, have fun then.
Bye, sir.
Bye bye.